Hello everyone, I hope y'all are doing well. This is Lesson 11, Inheritance. In this lesson, we will be going over inheritance in general, subclasses, superclasses, the extends keyword, the has a relationship, the super keyword in terms of methods as well, overriding methods, overloading methods, inheritance hierarchies, superclass references, and then we will revisit the toString method and the equals method for objects. Alright, to get this lesson started, I'm actually not going to go over to this folder where we have currently saved everything. Instead, I'm going to create a new project, and the way how you do that is you go to BlueJ and give it a second to load. Then you're going to want to go up here to Project, New Project. Alright, and I'm going to name this project lesson_11. Alright, and I have saved it to my desktop. You can save it wherever you feel like. So I've created the project and it's saved over here in my desktop. So let's talk about inheritance. So in Java, all classes can inherit attributes, or in other words, instance variables, and behaviors, in other words, methods, from another class. The class being inherited from is called the parent class or superclass. The class that is inheriting is called the child class or subclass. When one class inherits from another, we can say that it is the same kind of thing as the parent class, the class it inherits from. For example, a car is a kind of vehicle. This is sometimes called the is-a relationship, but more accurately, it's a is-a relationship. A motorcycle is a kind of vehicle. All vehicles have a make, model, and year that were created. All vehicles can go forward, backwards, turn left, and turn right. Inheritance allows you to reuse data and behavior from the parent class. If you notice that several classes share the same data and/or behavior, you can pull that out into a parent class. This is called generalization. So the first thing I'm going to want to do is let's talk about something common. Courses. I'm pretty sure all of you guys take courses. For example, you may be taking a computer science course. All right. So let's create a course class. All right. And I'm going to drag this over here to the middle, and we're going to open the editor. So what is the common structure for a class? So you do public class course. All right. Then we're going to have our brackets, and I'm actually not going to put in our main method. We're going to have our private instant variable, constructors, methods, all of that, how we write a class. And if you forget how to write classes, go check out the writing classes video. So what are some things that courses have? So each course has a title. So we're going to want to create a private instance variable called title. And it's going to be a string. And it's going to be called title. All right. What is another thing each course has? Well, each course has a student roster. So I'm going to create an array list of strings, right? Array list, and that is going to be full of roster. All right, so those are two common things in a course. Now we got to add in our constructors. So I'm going to have two constructors. One is the no argument constructor, in other words, the default constructor, and one is the one with parameters. So let's get to it. Oops. So I actually need to import java.util.star so that we can use array list. All right. So we have public, and then remember it has to be the same name as the class, so it's course. We're going to have our parentheses, and this is where we're going to write our constructor. So titles. So since we are talking about computer science, I'm just going to name this AP Computer Science A. All right, so that's going to be my default title if the user doesn't enter in his or her customized course title. And then we're going to say roster. First going to have to set it to a new array list, right? Because it's only been declared. Array list. And I'm going to make that of strings. And the initial capacity is set at 0. All right. And then let's add in like 3 names. So I'm going to add in some common names. So we have Sam, roster.add Bob, and then roster.add, and I'll add Nick. All right, so there's our default constructor. Now let's add in our customized constructor. So we're going to have public and course. And then what we're going to do is string init title, and I'm just going to have an array list just in case the user want to put in his or her own array list for the roster, and I'm going to name it init roster. All right, pretty simple, and all we got to do is initialize the private instance variables to the values within these parameters. So let's do that. So title equals init title, and roster equals init roster. All right. Then I'm going to want to have some accessor methods for each of these private instance variables. So let's do that. Public, whoops, misspelled that. Public string get title, and all we're going to do is return the title private instance variable. And then I'm going to have public array list. We're going to return an array list of strings, and I'm going to name this get roster. All right, and no parameters. And all I'm going to do is return the roster array list. All right, so we have a pretty basic class over here. So we have title, roster, we have accessor methods for each, and 2 constructors. Pretty simple. So now think about it this way. So if we decided to create a class called AP course, all right? So let's name this AP course. All right? Think about it this way. All AP courses have a title as well, and all AP courses have a roster, right? So think about it this way. Why would I need to recreate these private instance variables, recreate the constructors, recreate these methods, when all we can do is just use these same methods, right? That's what inheritance allows us to do. It allows us to use the variables and attributes of each class in another class so that we don't have to rewrite all of that code, right? Because imagine it, this is a very simple class, right? What if these classes get super complex? Do you really want to rewrite all of this code just to create another class that has maybe 1 or 2 things that are different from this class? No, because the thing is, AP course, it does have its own things that are different from the standard course, right? But it also has some of the things that courses does have. So why do we need to recreate these things when they already exist? So let's talk about how to do that. So we create a new class, and we're going to want to open the editor. So think about the common syntax for a class. We have public class AP course, and then we just go over here and add in our brackets, right? And we're all good. But here is where the extends keyword comes into play. So the extends keyword, it allows you to inherit from the other class. So we do extends course. All right. Essentially what this means is that AP course is inheriting from the course class. That's all extends does. So this is what I like about BlueJ. It shows you an error with the inheritance hierarchy. So let's get to it. So we have already created the for the title for the course and the roster. So what's something different that AP courses have? Well, they have an AP exam date. So we're going to do private string AP exam date. All right. And then we're going to want to have our constructors. So we have public, and it has to be the same name as the class, which in this case is AP course. And we'll have our default constructor. So the thing is, all right, So we have our constructor. How do we actually call this constructor, right? Because we need to call this constructor since we are also using these private instance variables. Well, the way how you do that is using the super keyword. In the super, all that means is the superclass. So think about it this way. AP course is now considered the subclass, and course is now considered the superclass. This is now the parent class, and this is now the child class. So super just allows you to access attributes from the superclass, all right, which in this case is the course class. So we just need to call the constructor. So we call super, and then we have our constructor with no parameters. So all that's going to do is call the default constructor. All right, now that we have called the default constructor and initialized those private instance variables, we need to set a common AP exam date. So AP exam date, all right, so I'm going to set that equal to, let's think about it this way. When do most AP exams happen? They happen in May, right? So let's do 05. I'm just going to put in a random date of 14th, and the year this year is 2020. All right, pretty simple. That's the AP exam date, and everything ended up working out. So we have initialized the title and the roster, and we have also initialized the AP exam date within the default constructor. All right, but what if the user wants to enter in their own values for the title, the roster, and the AP exam date? Well, let's create another constructor. So public AP course, and then we're going to have our parentheses, and we need our parameters. Well, the thing is, you just can't, this entire thing won't be copied. You need to add in these parameters, right? Because the user needs to be able to enter in the title and the roster, all right? So we have that, and then there is one more parameter that we had, and that was the exam date. So we'll have string init exam date. Oops, and there is AP, all right? And then we are done with this constructor. Let's make this a bit wider so that we can see all of our parameters, add in our brackets. And so this is the thing. We don't have to initialize all of this. All we have to do is just call this constructor. And ArrayList is throwing us an error because we haven't imported it. So let's just do that really quickly. Import java.util.star. And that should get our ArrayList error fixed. And so back to calling this constructor. Well, remember how I had talked about the super keyword? The super keyword allows you to access attributes of the parent class whenever you want. So we just have to call super, and here we just called the default constructor. Well, here we have a specialized constructor. We can call the one that has two parameters, all right? So all we're going to do is want to put init title over here and init roster based on what the user inputs. So that should call that constructor and initialize those private instance variables. And then we have to do AP exam date. Whoops, AP exam date, and we're going to set that to init AP exam date. All right, that makes sense. The reason why we just couldn't initialize title to init title and roster to init roster is because we don't have any private instance variables over here that are called title and roster, right? So the only way to access those private instance variables is using the super keyword and calling the constructor for that class. All right, so there we are. And then, we can go in and add our own things. So we need to have our accessor method. So we have public string get AP exam date. All right. And then what we're going to do is just return that private instance variable. Return AP exam, date. All right. There's our class. Again, a pretty simple class, and we have utilized everything within this class. So anytime we create an object of this class, we can call these methods or these constructors whenever we want. So let me show you an example. So let's create our main method. So I'm just going to name this main method, right? And I'll have this down here and open editor. So I'll delete everything. Public class main method. This is pretty simple. And then all we need to do is add in our main method. Public static void main string args. All right. Let's say we created an AP course object. So AP course, let's just say AP equals new AP course, and I'm just going to set in our own things. So this title, I'm just going to name it APCSA. All right. Roster. All right, let's first create an array list. Array list string students equals new array list string and no initial capacity, and we need to import the array list dot star. All right. So let's add in some names. So students dot add. I'll add like Rob. We'll add in Carter as one name as well. Carter. And students dot add. We'll add in one more, and I'm just going to name it Elliot. All right, so all we need to do over here now is just add in our array list. So we'll put in students here. And then all we need to put in is an exam date. So let me think, 05/16/2020. All right, that should make sense. And now we have created an object of the AP course class. So let's walk through it. So we created an object of the AP course class. All right, so, and we called the constructor with 3 parameters. Let's see what happened. So we called this constructor super init title and init roster. So all that did is call the constructor in the course class, and it initialized the PIV's title and init title. All right, we can do that. And then we did AP exam date equals init AP exam date. So it just set it to whatever we passed in the parameter. So what do we have? So we have one method over here. Let's see what happens when we print that out. So system.out.println. All right, and I'm gonna just put in ap.get AP exam date. Call that, see what it prints out. There we go, printed out the AP exam date. And let's see, all right, well, I want to get the title. Well, we can also call get title. Get title, see what that happens. Oops, it didn't throw us an error. All right, let's see what happens. There it is, it gave us the title. Now you may be asking, wait, I don't see get title anywhere over here. How did it not throw you an error? Well, the thing is, remember, we inherited from this class. So we're able to access any of these methods. So this AP course can access any of the methods from the course. So that means we can access this method and it just returned the title of whatever we had passed. So that's the cool thing about inheritance. So if I do get roster, it won't throw me an array, any error either. It'll actually print out that array list. Here, let me show you. Run our main method. There you go. There's the array list. See, inheritance is pretty cool. So now you may be asking, all right, does it work the other way? So say we created another course. but this is just going to be from the course class, not from the AP course. So course AP equals new course, and I'm just going to name this pre AP CS, right? And then the roster is just going to be students. We cannot put in an AP exam date because this constructor only has two parameters. It only has the title and the roster. So that's all we can do. And you may be asking, all right, we can do get roster. That shouldn't throw us any errors, right? That is correct. See, we can do that because all we're doing is just utilizing any of these methods. So this is just a common class. We don't have any extends. We're just able to use these methods and, do whatever we want. Let's see what happens when we try doing ap.get AP exam date. It's actually going to start throwing us an error. The reason for that is because course is not inheriting from AP course. AP course is inheriting from course. So think about it this way. AP course is a course, but not every course is an AP course. So because we are not extending from another class, these are the only methods that we have, and I don't see get AP exam date anywhere within these methods. So that's just how it works. And there's also one more thing you should probably know. Okay, let me just get rid of that. Say you leave out the super keyword. See what happens. You're not throwing an error. The thing is, Java will actually resort to calling the default constructor of the class that you inherit if you do not call any super keyword. So say that we had removed this super keyword, right? What's actually going to happen is Java is going to call, it's going to go to the inherited class, right, course, and it's going to call the default constructor. That's the standard thing. Whether you put super with no parameters or you don't put that at all, it's the same exact thing. It's going to yield the same result. So let's give it a try. So say we do AP course, and I'm just going to name this APCSA, right? And let's put in an exam date, 05/09/2020. All right. Whoops, need to add in that last one. And whoops, this needs to be AP course. All right. So what's exactly going to happen is it's actually not going to print out APCSA whenever we do it. So let me show you. Let me give it to you. Here, I'll just print out the roster. So system.out.println ap.get roster. Let's give that a try. Call it. Wait, but that's a different array list than the one that we created. Why did that happen? Well, the reason is, look at what happened here. So we called the AP course with the 3 parameters, all right? Let's go over there and see what happened. So we call this constructor, all right? And remember, whenever the super keyword isn't used, it's just going to call the default constructor. So and that happens always at the beginning statement before any code in the constructor is run. That super is called with the default constructor. So since this default constructor is called, the roster was actually set to this array list that we created in the default constructor. And the title is also set at this. The title is not APCSA. The title is AP Computer Science A. But the exam date was initialized properly because that's what we did. But the rest wasn't initialized properly because we forgot to put in our super keyword, which we have to put in init title, which initializes the title, and init roster, which initializes the roster. Now it will work properly. Initially, what was happening is it was the same thing as this. Remember, this statement is always called no matter what for the default constructor. So again, if you leave out the super constructor, Java will automatically just call the no argument or default constructor of the parent class. All right, now let's talk about overriding methods. So, and this is where we get into the toString. So every class, it's common to have a toString method. So let's create that. Public string and toString, right? And this is how we would print out the object. So let's think about it this way. So return, and let me think. Course title, and we're just going to want to put title, and then I'm going to create a new line, and we're going to want to put roster, and we'll put in the roster. So roster. So let's give it a try. Say we created the course AP equals new course. I'm just going to call the default constructor to make this simple, and we call AP, right? What's going to happen is it's going to print out what we wanted. See, course title and the roster. Here, I think that it added an extra space in. Oh yeah, this space isn't needed. Let's give it another try. All right, there you go. That's the toString method. And remember, toString is what is called whenever you call the object so that it doesn't print us a memory address that none of us understand. It actually puts it into visible characters that are understood by a human. So think about it this way. We call the toString method. Say we do AP course now, right? Let's create an AP course, and I'll create a default AP course as well. And we print out AP. Let's see what happens. It printed out the same thing. Why? Well, we also wanted the AP exam date to print out. Why did that not print out? Let's go through it. So we created a new constructor of the AP course. All right, that's over here. The super keyword is automatically called. All right, and there you go. There it is over here. It sets it to AP Computer Science A and gives us an array list for the roster. And then what happens is we call the toString method. So Java's first going to search through this entire class, and it did not find a toString method, so then it's going to check the class that it inherited. All right, so let's go through here. It finds a toString. So what's actually going to happen is this method is going to be called. So you're going to be like, all right, how do we actually get that AP exam? How do we actually get the AP exam date to get printed? Well, this is where overriding methods comes into handy. So you might have seen this. You do @override, and what you're going to want to do is do public string. You write out the method exactly how it is written out over here in the class. So we do public string toString, right? And then what we're going to have to do is return. I'm using more or less the same code, and we're just adding another element to it, and that's the exam date. So let me just put that over there. Then we're going to do plus, add a new line, and AP exam date plus, and then AP exam date, right? Let's extend this out so we can see everything, right? And there you go. So now you may be asking, why is it throwing us these errors? Title and roster. Well, there is no private instance variable called title and roster. It doesn't work like that. You can call methods from this in this class, see, but you can't call the private instance variables because it's private. It's private. You cannot call these private instance variables because they belong to this class. So the way to do it is, remember, the super keyword. So you do super.title, super.roster. So essentially what super is going to do is it's going to check super, it goes to the parent class, and then it checks, all right, there is a title here, we can do that, and super.roster. That won't work either. The only time that you can use super is with methods. That's where we get into super methods. So the only way to get the title, that's the reason why we created these accessor methods. That's the only way to get them. So you have to do super.get title. Super.get roster, and let me add in those parentheses. That's where it will work. You can call the methods, but you aren't able to call the private instance variables. That's one thing about Java, or otherwise it'll throw you an error. So that's how you're going to access the private instance variables from the parent class. That's why it is so important to create accessor methods and mutator methods. We're not really going to be discussing that much in this lesson, but accessor methods is definitely something you should include when creating a class for each private instance variable that you have, because it came into use over here. See? Now let's give it a try. Now that we have finished all those errors. And there you go. Everything has been printed out according to how we had wanted it. The reason for that is, let's go through it. So we created a new AP course, all right? So we call the default constructor. It's going to call the super keyword, super constructor. It did all this, all right? That seems to be working out so far. And then AP exam date is set to that date, all right? That date seems correct. And then when we call the toString method, here, just so that I'm not confusing you, I'll add in toString, but remember, it's the same thing as just printing out the object. So we call toString, right? And what's going to happen is it's going to search through all of this, right? And it said, all right, we found an override, and we're overriding the method in the parent class. That's essentially what it means. And we're just going to print this out. We're just going to return this entire thing instead of this toString. And then it just printed out, and it did it correctly. And let me tell you something. This override keyword is also unnecessary. It's just there to check your syntax, to see if you had correctly done the method header. Say we had override, right? Override, but I added in an extra parameter on accident, right? It's actually going to throw us an error. All override is doing is saying if we have correctly done the method header. Since we have incorrectly done it, it's throwing us an error because it did not find anything within the parent class that has toString with an integer parameter. So this is just an extra check for ourselves. And now if we do it correctly, exactly how this method header is done, it will not throw us an error. But again, this override keyword isn't necessary. It'll print out the same exact thing either way. Here, let me show it to you. There you go. The reason for that is because Java is first going to search this code for saying, all right, we called it toString. It's first going to search the AP course class for a toString method. And if it doesn't find one, then it will resort to go over here. Since it found a toString method over here, it didn't have to go on to the parent class. It just finished it off right here. So hopefully all of that made sense. And again, the super keywords on the method are usually called when you want to call the parent class version of the method, cite the subclasses overrides the method, right? We're calling the parent class methods over here using the super keyword. Remember, super, and it's tied to a method. Now you may be wondering, all right, we talked about overriding methods. What's the difference between overriding methods and overloading methods? Remember, overloading methods, essentially overloading is whenever you have a method with the same name, but it has different parameters, right? This would be an example of overloading. This would be an example of overloading. Whoops, public string toString. Yep, that would be an example of overloading. We have methods that have the same name, but they have different parameters. That's overloading. Overriding happens when you are trying to change the method that you have inherited. So you want to specifically change the toString method. That's when you override. Overloading is when you have methods with the same name, but you have different parameters. So just some vocabulary over there. All right, so let's talk about inheritance hierarchies. So I'm going to leave all of this, right? Here, I don't need any of this anymore. I can just push this all over to the side. I don't want you getting confused with any of this. We're going to be doing something new. So let's say we have a parent class called shape. All right? Shape. Completely independent, right? And it doesn't matter. I'm actually not going to go through here and create the class. I'm just trying to illustrate a concept over here. Now, think of a type of shape. Well, we have rectangles, all right? We have a rectangle. Here's a rectangle. What other kind of shapes do we have? Well, we have a triangle. Triangle. All right? Let's think of another one. What else do we have? We have ellipses. So, ellipses. All right. So, think about it this way. All rectangles are always shapes. Triangles are always shapes. Ellipses are always shapes. And then think about it the opposite way. Are shapes always rectangles? No. Shapes are not also always triangles. Shapes are not always ellipses. That's why this shape is the parent class, because all three of these are examples of a shape, but shapes do not always have to be these. Shapes can be anything. That's why shape is going to branch from each of these. Here, let's do it. So I'm just going to open the editor just to add in this thing. So public class rectangle, let me do it, extends shape. All right, there we go. There's the arrow for there. Let me open up this editor. Public class triangle extends shape. All right, compiled properly, and then we have ellipses. So let's do that. Public class ellipses. And we need to have extends shape. All right. So you can see everything over here. Rectangle inherits from shape, triangle inherits from shape, and ellipses inherit everything from shape. Because each of these are going to have something in common, and that's shape. Shape is the thing they have in common. Think about it this way, all right? Rectangles. The rectangle can also be a parent class. Give me an example of a rectangle. Well, we have squares. So square. This is a commonly known thing. Squares are always rectangles, but rectangles are not always squares. Rectangles do not have to be squares, but squares are always rectangles. Works the same way. So let me just add in that arrow. Public class square extends rectangle, right? And then put in our arrow. See, that makes sense? And same thing works for ellipses, right? Circles are always examples of ellipses, but ellipses are always not equal to circle. Same analogy works. So let's do it. Public class circle extends ellipses. Oops, I need to add in those. All right. So now let's walk through this. If there are some methods within shapes, will square be able to use it? Yes, because the thing is square inherits rectangles, which inherit shape. So square will have the same method. Squares will be able to use the methods within shape. But will the shape class be able to use the methods within square? No, because shape is its own independent class, and it is not inheriting from another class. So the square class can use the methods from the shape class, but the shape class cannot use the methods from the square class. Let's look at another example. Triangle can use the same methods as shape. Circle can use the same methods as shape. But can triangle use the same methods as circle? No. Circle is like a broader branch of it, and circle has its own specific method, and no one is inheriting from circle, so that's why triangle, since triangle is not inheriting from the circle class, triangle cannot use the methods in the circle class. Same thing works. All you have to know about these things is that wherever the arrow points, those are the methods that it can use. Square can use rectangles, square can also use shape, rectangle can use shape, triangle can shape, ellipses can use shape, and circles can use ellipses, and circles can also use a shape. But rectangle cannot use the methods from ellipses because these are not related. Just because they share a common ancestor doesn't mean that they are the same. That's how it works. Childs can inherit from the parent, but childs cannot inherit from each other. Siblings cannot inherit from each other. Only childs can inherit from parents, but parents cannot inherit from children. Think about it that way. All right, so now that you've understood that, we can delete all of these since these are of no use to us anymore. So that it's not confusing you anymore. And let's bring this back. So we have our AP, and then I'm going to be putting our main method over here. Right? That makes sense. So the next part about the lesson that we need to talk about is superclass references. So a superclass reference variable can hold an object of that superclass or of any of its subclasses. For example, a shape reference variable can hold a rectangle or square object. This is a type of polymorphism, which will be defined in the next lesson. The variables declared of shape can hold objects of its subclasses. So in this example, let's think about it this way. AP courses can hold objects. The course can hold objects of the AP course. So let me show you what I mean. So let me just fix this one and put in these parameters. So init title, and we will also put in init roster, and then I'll just add in the super keyword over here just so that we avoid confusion. Right? There you guys go. So, whoops, semicolon. All right, so let me show you what I mean. All right, so think about it this way. We have course, right? And let's just name it C1 equals new. Watch this. We can create a new AP course of that, right? Say we add another class. Let's name this like honors, right? An honors course, and say it also inherits from the course class. Public class honors extends course. Right? Whoops. There you go. So let's go over here and let me show you what I mean. Course C2 can also be called honors. Watch that. See, that also works. The reason for that is because course can hold honors and course can hold AP course because they are both examples of course. Course extends from a course inherits from the course class. AP course inherits from the course class. So that's why it can be stored within a course variable. Honors is also extends from the course class. That's why it can also inherit from the course class. And that's why course can also hold its variable. It works that way. But what if I try to do it like this? AP course let's do A1 equals new course. That will actually throw you an error. The reason for that is because course does not inherit from the AP course class. You cannot store an AP course inside, you cannot store a course within an AP course, and the reason for that is because AP course is more complex than course. Course is just a simplified version of AP course. Remember, AP course has an extra parameter. But the reason why you can store course over here is because course is less complicated than AP course, so you can always store a more complicated thing inside a less complicated thing, but you cannot store a less complicated thing in a more complicated thing because you need space for that parameter, and that parameter is nowhere to be found within the course class. AP course has all the parameters that course has, so that's why you can store it there. This is most commonly used whenever you have an array list. So array list, and you want to create a bunch of courses full of honors and AP courses, but you're not able to do that within variables. So the way how to do it is you can't have an array list hold two types of things. So the best way to do it is just hold a course, right? And then these are full of courses equals new array list, and this is full of course. Oops. And add in those parentheses. And then this is common whenever we do this. So course dot add new honors and course dot add new AP course. Oops. Add in those parentheses. See, that's where this is more commonly used whenever you want to store it within an array list. But you can't hold honors and AP course within an array list. An array list can only hold one type of data type. So that's why we just created it of a course, because course can hold honors and AP course, because honors and AP course inherit from course. So, and then there was one more thing we had to talk about before we wrapped up today's lesson, and that was the dot equals method for objects. So let me just talk about that. So say we create one public boolean equals, and this has to be another AP course, and obj. And all we need to check, is super dot get title. Here, let me make this a little less complicated. We'll do it in course that's not inheriting anything. So public boolean equals, and let's do course obj. So all we need to check is if this dot title, or we can just do title, remember this isn't necessary, equals obj dot get title, and and roster equals obj dot get roster. See? Maybe missing something. Oh yeah, you need these in if statements. If that equals that, and roster equals obj. If both of those statements are true, then we're going to return true, and else return false. Right? Pretty simple. So what's going to happen is, say we go over to our main method, right? So we have course C1 equals new course, and let's just put in a title. I'm just going to name this course A, and I need to create another roster. So I'm only going to create a roster of 2 students just to speed things up. So strings students equals new array list string at an initial capacity of 0, and students dot add Rob and students dot add Bob, and let's just add in one more, students dot add Sam. All right, and then we'll just add in students as our array list of strings that represents the roster, and let's create a course C2 equals new course. I'll just use the default constructor. And remember, just a reminder for what the default constructor does, the title is going to be set to AP Computer Science A, and this is the roster we're using, as opposed to here. So now you want to know if both of those objects are equal to each other. So what you're going to do is do C1 dot equals C2. Because the parameter inside of the equals method was a course object. So we put in a course object. And then we're going to see if both of those are equal. Let's give it a try. False. They are not equal to each other because both of the parameters are not equal to each other. Say we set both of these to default constructors. They are bound to have the same values in each of the private instance variables. So now it should return. Let's give it a try. So C1 dot equals C2, compile and clear it out. And there you go. Reason why it's printing out false is, let's go through it and see what's actually causing the error. So we have title. All right, so let me just add in this dot title, right, equals obj dot get title. All right, and this dot roster equals obj dot get roster. All right, so let me show you what's actually causing this error. Remember array lists. They all point to objects. They give directions to objects. So we are creating a new array list with every constructor. Think about that. We are creating a new array list with every constructor, which means there are going to be 2 separate memory addresses when we create it. So this constructor is called 2 times, which means a new array list is created with every constructor. And those array lists are, whenever we create a new thing, it's going to create 2 new boxes, and we're going to have different directions to each of those boxes. They're not going to be pointing to the same box. That's why this is throwing us an error. Say we only limit this to 1 parameter, right? Say I only care about the title. Then this should return true, because title is a primitive type. It's a primitive type. Array lists were objects, which means they have different memory addresses, and whenever you create a new type of object, you're going to have 2 separate memory addresses. So since those 2 memory addresses were different and we were comparing those array lists, it was comparing 2 memory addresses, and of course those memory addresses are going to be different. Since string is a primitive type, we can just compare each one. So I hope all of that made sense to you. Again, if you did not understand anything within this lesson, please do not hesitate to scroll down at the bottom of this page and find information regarding how to schedule a tutoring appointment. I hope you all have a great rest of your day.